Assalamualaikum and hi, my name is Wan Ali Halibuti Muhammad. My matrix number is A24A3605. Today I will be presenting Introduction Life Insurance Data Analysis. This dataset has 1,338 records with information like age, BMI, gender, number of children, smoking status, region, and yearly insurance charge in Malaysia Ringgit. The goal of this assignment is to see how we can use statistics to understand the data and find useful patterns. This kind of analysis help insurance company to make a better decision, like setting fair prices and grouping customer based on risk.
Assalamualaikum and hi everyone. My name is Aladini binti Adenin and my metric number is 824-83650. Today I will be presenting about sampling and data collection. Let me highlight that we are using the JASP application or tools to do this sampling. There is 1,338 data, but we only need 500 samples in this case. These are the steps that we need to follow to randomly select the 500 data. Step 1. Access the plus button and select the R console to make it appear on the upper navigation. Step 2. Open the given data file, which is dataset C. Step 3. Click on the R console and paste the given code. Step 4. Replace the XX in the bracket to the last two digits of your metric number. In this case, I use my metric number 824-83650, so I change the XX with 50. Step 5. Click on the run code and the 500 data needed will be generated quickly. Lastly, save the file and you are done.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ainin Sofia binti Abdullah and my metric number is 824-83589. So today I will present about this statistic of numerical descriptive measures. Numerical descriptive statistics are numbers that are used for summarizing and describing the most significant characteristic of a data set in a straightforward and meaningful way. They help us understand the general direction of data. They are one of the basic tools in statistics for understanding data and interpreting it in a meaningful way. Measures of central tendency is a technique of employing mode, median, and mean in describing. We provide here some numerical descriptive measures which are suitable for measuring central tendency. We choose here gender and age. So firstly, we need to click on descriptive and next descriptive statistic. The second step, we have to insert the variable, that is gender, into the variable box, then wait for JSP to generate it. On the third step, click on statistic, then click on mean, median, and mode box at central tendency, and also click on the table part, then click on frequency tables. For step 4, JASP will generate this output like below. And then step 5, to run the report in the mean and standard deviation of the numeric variable, we will choose age to complete the overall. To accomplish this, go to descriptive and choose descriptive statistic. And for the next step, step 6, insert the variable age into the variables box. And the last step, that is step 7, JSP will generate this output. That's all. Thank you.
Assalamualaikum and hi everyone. My name is Nur Ansha Mimiti Muhammad Zubair and my metric number is A2483563. Now let's move on to section 3.2, graphical representation. The most effective way to help the readers understand statistical data is by showing it visually. Instead of showing the number in the table, we can make the information more clear by using graph and chart. So how we do this in JSP? Let me show you the step. Step 1 is click on basic plot, then tick on distribution plot box. Step 2, JSP will generate this output of bar graph. Here you can see the two examples of showing age and gender distribution.
Next, I'll be talking about hypothesis testing and two important statistical tests, the t-test and ANOVA. First, hypothesis testing is a statistical method that helps us make conclusions about a larger population by analyzing a smaller sample. Instead of guessing, it allows us to use data to support our decisions. Second, in this process, we form two hypotheses. The null hypothesis suggests there is no effect or difference, while the alternative hypothesis suggests there is a meaningful effect or change. The purpose is to test whether the sample data provides strong enough evidence to reject the null hypothesis. Third, if we want to compare the average result between two groups, we use the independent sample t-test. For example, we can use it to check if insurance charges differ between males and females or between smokers and non-smokers. Fourth, if we are comparing more than two groups, we use ANOVA, which stands for Analysis of Variance. For instance, we can use ANOVA to check if insurance charges or BMI vary by region, such as Northeast, Southeast, Southwest, or Northwest. In conclusion, hypothesis testing along with the t-test and ANOVA are powerful tools that help us make informed decisions based on real data and not just assumptions.
Next, I'll be presenting the result of a statistical analysis comparing BMI between two groups, which is smokers and non-smokers. We use an independent sample t-test to determine if there is a significant mean difference between these two groups. So we begin by stating our hypothesis. The null hypothesis assumes that there is no significant difference in BMI between smokers and non-smokers. The alternative hypothesis suggests there is a significant difference. So we use a 0.05 significance level to test this. So our first step was checking for normality using distribution plot. This helped confirm whether the data met the assumption for a t-test. Once confirmed, we proceed with the independent sample t-test using JASP. We also request a descriptive statistic to better understand the data. So in terms of group data, the smokers group had a mean BMI of 30.54 with a standard deviation of 6.23. The non-smokers group had a slightly higher mean BMI of 30.97 with a standard deviation of 5.94. The independent sample t-test produced a p-value of 0.518. Since this is greater than 0.05, we fail to reject the null hypothesis. This means the difference in BMI between the two groups is not statistically significant. So to conclude, although non-smokers show a slightly higher average BMI than smokers, the difference was small and not significant. Therefore, based on this analysis, we cannot say that smoking status has a clear effect on BMI.
Next, I will continue the presentation. My name is Nur Raihana and I will present about analysis of variance. ANOVA is a statistical method used to compare the means of three or more groups to determine if there are any statistically significant difference. ANOVA also to see how it affects a continuous dependence variable. For hypothesis statement, which are hypothesis null, there is no significant means difference of BMI between the region, lowest, shortest, and shortest. For hypothesis alternative, there is a significant means difference in BMI between the regions, lowest, shortest, and shortest. For p-value less than 0.05 means that we reject hypothesis null and accept hypothesis alternative, which is there is a significant means difference of BMI between the regions. For ANOVA, we using one-way analysis. First step, we checking the normality test for the data using JSP. So, from the variables analysis, all the data are almost achieve normality. The histograms illustrate a bell-shaped graph between BMI and regions. Since one-way ANOVA is a parametric test, we are considering the variable BMI and regions that are reasonably close to normally distributed. The table shows the comparison between mean BMI and region, n equal to 496.
So, based on the table, one-way ANOVA was applied post-analysis with the Turkey test with the region. P-value is less than 0.001. So, the table shows the mean BMI and standard deviation for 4 regions as well as the result of a one-way ANOVA test to compare the means. The ANOVA test generates a significant F statistic is 12.99 with a p-value less than 0.001, showing significant difference in BMI between regions.
I will go to the step 3, which is post-hold test. To do the post-hold test, we need to return the ANOVA dialog box and choose the post-hold and choose the true key and also confidence interval and click continue and OK. This post-hold test is the section of the show the pairwise comparison. It tests which pair of the region have a significant BMI difference. And after the ANOVA was found, an overall significant effect. From the output of the GASP, we know that South East is considerably different from other regions. It has significantly higher BMI than Northeast, Northwest, and also Southwest, because the p-value is less than 0.05. We know that Southeast region has a significantly higher BMI than other 3 regions because the BMI difference between Northeast and Northwest or between Northwest and Southwest is not significant, meaning that their average BMI of statistically similar. This confirms the ANOVA result. There are significant BMI difference between regions, mainly driven by the Southeast having the higher BMI. I will continue with the descriptive statistic. This section, I will summarize the BMI data for each region. That we can obtain the mean and standard deviation on the BMI based on the region that following by the tab 2, but choose the descriptive statistic under the display or in the option. For the summary, the Southeast is the highest level of the BMI, which is 33.209, and followed by the Southwest 31.16, and also Northwest 30.089, and also the Northeast 28.9. The Southeast also has the largest spread on the standard deviation, which is 6.206, meaning that the BMI score very more widely there. Next, we will go to the interpretation. So this is a table that compares the average body mass index, or the BMI, of the people across the 4 regions, which is from Northeast, Northwest, and Southeast, and also Southwest. This is based on the sample of the 500 people. For the first column, given that the variable, this is a list of the 4 regions that have been compared. For the second column is a BMI, mean and standard deviation. From the column, we know that the highest average of BMI is from Southeast, which their mean is 33.209, and also their standard deviation is 6.206. And also the lowest average BMI is from Northeast, which means that their mean is 28.9, and also their standard deviation is 5.904. For the third column is a F statistic is 12.985, and also their degree of freedom are 3. For the last column is a p-value. So the p-value is less than 0.01, which means that there are very slow evidence of significant difference in average and between regions. So the one-way ANOVA was applied at a p-value. Post-hold analysis with a Turkey test showed a significant difference between Southeast and Northeast, which p-value is less than 0.01, and so Southeast and Northwest p-value is less than 0.01, and also Southeast and Southwest p-value less than 0.05. Because of the p-value less than 0.05, thus there is a significant mean difference of the BMI between the 4 regions, so we reject the HO and accept the H1. So in a calculation, an independent t-test is used to compare the mean between the 2 separate groups. In contrast, a one of ANOVA compare means among the three or more independent groups. It is precisely that normality and homogeneity of the variant assumption that must be done and be met to do the one-way ANOVA.
So lastly is the conclusion. In our analysis, we use several statistical methods to study life insurance dataset. We started by selecting a random sample to make sure the results were fair and reliable. Using descriptive statistics, we found some clear patterns. For example, BMI level were different across regions, and insurance charges were higher for smokers. Next, we used the t-test to see if there was a difference in BMI between smokers and non-smokers. The results showed that there wasn't a big difference. Okay, then we apply ANOVA to check BMI to check if BMI varies by regions, and it does. The Southeast region has the highest average BMI. This shows that where persons live can affect their health and insurance costs. Overall, this assignment helped us apply what we've learned in class to real-world data. It showed that statistics isn't just about numbers, it's a useful tool to help businesses make a better decision.